Good day, everyone. So, in today's topic, I'm going to go over everything you ever wanted to know. Well, maybe not everything, but most of the things you ever wanted to know or should know about an atom. So, what are atoms? All right, everything surrounding you as you sit there watching this presentation is made of atoms. Your computer table, the chair you might be sitting on, the clothes, even yourself is made of atoms. So let's look inside and see what atoms are. Well, if you look deep into the atom, you will notice at the center there is this thing which we call the nucleus. And in the nucleus, there are two things, positively charged protons and neutral charged neutrons. Okay? So we have some positive things and some neutral things. You add up those charges and you find out that the overall charge on the nucleus is positive. Well, not because the nucleus is positive, but because the nucleus uh, is contains protons and neutrons. And if you add those up, the overall charge on the nucleus is positive, right? Okay, so this thing that go around the atom is what we call the energy level, right? Now, there are really no rings there, but these are the places where the electrons are located. So these are the energy levels. Sometimes we call them rings, sometimes we call them shells, sometimes we call them orbitals. Now, electrons have a negative charge. They're attracted to nucleus, and that's what keeps them in energy levels or keeps them from flying away. Okay? Now, there's a law in electric charges which states that opposite charges attract each other and same charges repel each other. And since electron is a negative charge, it is attracted to the nucleus, which is a positive charge. All right? Now, the electrons are moving very quickly so they don't fall into the nucleus. But there's this kind of balance between the charge and the speed that keeps them flying around very, very quickly around the nucleus. Okay, now we're going to talk more about these particles, protons, neutrons, and electrons in a few moments. But let's just say some fascinating, interesting thing about the atom. Okay, now this is the most common definition of an atom. It's the smallest unit of an element. If you think of the periodic table of the elements, some of the elements that you can find in the periodic table are gold, silver, copper, calcium, isanium, oxygen, and a lot more. There are currently 118 existing elements. If you would look at your periodic table, there are 127 boxes, but only 118 are existing elements. The other boxes are there for those elements that yet to be discovered. Okay? Now, in order for something to be an element, it has to be an atom. You have to have an atom on it. So it has to have a nucleus and electrons. If you have just a proton, you really don't have an element. If you have just a neutron, you don't have an element. Or if you just have an electron, you don't have an element. Because in order for it to be an element, it has to be an atom. So it's the smallest particle, the smallest division of matter with a size of 1 times 10 to the negative 12. Also, they're the building blocks of matter. Like I said earlier, all this stuff that surrounds you is made of atoms, made of elements, infused atoms of different elements. So you put those elements together, like, for example, water, so H2O. Okay, water contains 2 atoms of the element hydrogen and 1 atom of the element oxygen. So we snap those things together like Legos. These elements are combined together to produce another substance which we call compound, as we have discussed in our previous lesson. Also, they're mostly empty space. Okay, so this is fascinating. You can see here we have this small nucleus. This space between the rings is empty. There's nothing there. Now, we're going to talk about some of the particles we said earlier, the protons, neutrons, and electrons. And let's start off with the proton. Well, everybody knows, maybe not everybody knows, but a lot of people know a proton has a positive charge, right? A positive one charge. And where are they? As what we said, they're in the nucleus. A positive charge in the nucleus. Now, they're so small, they're this small, 1.67 times 10 to the negative 27 kilograms. Negative 27, that's like 1.67 with about 26 zeros in front of it. It's really so small, okay? Anyway, the importance of protons is that they identify what kind of atom we have, all right? The number of protons in the nucleus tells you what kind of atom you have. That is what we call the atomic number. So hydrogen has one proton. The nucleus of all atoms with one proton are hydrogen. Okay, so that tells you the identity of an atom, which we know as the atomic number. All right. Okay, neutrons. Well, what's the charge on neutron? So the charge on neutron is 0. It has a neutral charge. And where are they? Well, they're also in the nucleus along with the protons. Now, their mass is the same. So the mass is approximately the same as proton, which is 1.6 times 10 to the negative 27 kilograms. So that is a really small mass. Now, what do neutrons do? What is their importance? So they hold together the nucleus. It's believed that they kind of mediate the strong nuclear force. You have all those protons in the nucleus. Well, all the protons are positively charged, right? So all those positives, they want to fly away from each other. They want to repel from each other. And it's the neutron. The neutron has a strong nuclear force that keeps the proton inside the nucleus. All right. Okay, so that's the protons, the neutrons, and now the last thing is the electrons. Now, electrons have a -1 charge, -1, and they are outside the nucleus. They're in the electron cloud. They're in the shells. They're in the rings, or they're in the energy levels. They're in the orbitals, but they are not in the nucleus. Okay, now their mass is even less than the other particles. It's 9.11 times 10 to the negative 31. So it is smaller compared with proton and neutron. And the electrons are involved in chemical bonding, which makes all the things that surround us. Okay, we will discuss chemical bonding maybe 2 weeks from now. Okay, so those are kind of 4 things: the charge, the location, the mass, and the importance that you should know for each of those things: the protons, the neutrons, and the electrons. Now let's take a look at the periodic table of elements. So the period on the periodic table are the rows, okay? So each row is called a period. Now the groups on the periodic table are the columns, and each column is called a group. or family. Okay, so here we go. Here is our typical periodic table. So the rows are called period, and there are 7 periods. Okay, 7 periods. We have 1, 2, 3, 4, 5, 6, and then 7. All right. Now, some of you might ask, why there's only 7? There are 8 and 9 rows here. But actually, these two you can see, the lanthanide series and the actinide series, these 2 rows down here, they actually go right in here like a puzzle. All right. All right. So barium, it will go down to lanthanide. Okay. And from radium, the actinide series would follow. Okay. So they should be this way. Why? Because if not, the periodic table would be kind of twice as long. Okay. So these two part of 6 and 7 period. Okay. So the lanthanide and the actinide series. And then the columns. Okay, so each column is a group, and nowadays we number them through or 1 through 18. Okay, so there are some periodic tables that have this 1A, 2A, and then 3B, 4B, 5B, and so on. Now we can just group 1, okay, and then 2, and then 13, 14, 15, 16, 17, 18, which is the noble gases group. Okay. Now here is a block on the periodic table. So this is the typical thing you can see. Now you should be able to really name most of the elements just by looking at this thing, which we call the symbol. Okay, and this is the symbol the symbol C, which stands for carbon. Okay, and the next thing is this number. So this number, this is the atomic number. Okay, so that is the atomic number tells us that in every atom there are 6 protons, because the atomic number is the number of protons in the nucleus. So every atom of carbon has 6 protons, and if you have an atom that has 6 protons in it, then it is also an atom with 6 electrons, an atom of carbon. Okay, so the number of protons identifies the atom. So 6 identifies the element 6. Protons equals carbon. So if you got 7 protons, then you have something else. If you have 5 protons, then that's not carbon. And then this number, the bottom, here is atomic average atomic mass. And we will talk about that later on. Okay, now, so let's try to exercise our brains. Okay, so oxygen. So this is oxygen. Okay, now, okay, O is the symbol of oxygen. And the question is, how many protons are there in a neutral atom of oxygen? Well, you know, for oxygen, this is the atomic number. Okay, this is the atomic number of oxygen. And the atomic number is also the number of protons in the nucleus. So therefore, every atom of oxygen has 8 protons in its nucleus. Okay, now, here's another question, a little trickier. How many electrons are there in a neutral atom of oxygen? Now, the key word here, of course, beside oxygen is neutral. It's neutral. So if it is neutral, we know the number of protons equals the number of electrons, or the number of electrons equals the number of protons, which is 8. All right. Okay, let's try the same things for another element. Okay, antimony. All right. Okay, so here is the antimony. So SB is the symbol for antimony. In Latin, they say stibum. So that is where the that symbol comes from. The Latin word for antimony is stibum. Now let's just answer the same two questions. How many protons are there in a neutral atom of antimony? Well, let's see. Okay, so it's 51 protons. And how many electrons are there in a neutral atom of antimony? Well, of course, it's 51 electrons. So if it's neutral, then the number of protons and the number of electrons has to be the same. All right? Okay, so let's have another one. Sulfur. So this is sulfur, right? So how many electrons is in sulfur? So the number of electrons and the number of protons has to be the same. So that would be 16 protons. Okay, so it has an atomic number of 16. Now we want to name an element whose neutral atom has 53 electrons. So this time, I want the name of the atom, okay? Or the name of element. So it's neutral, it has 53 electrons, okay? And the answer is iodine. So here is your iodine. All right, let's have another problem. So the name of an element whose neutral atom has 36 electrons. Okay, well, if it's neutral, then it must also have 36 protons. And we look for atomic number 36. And that is krypton. All right, so that's how you use your periodic table. Now, isotopes. Okay, so atoms of the same element with a different number of neutrons are called isotopes. So the element hydrogen, we're going to talk about the 3 isotopes of the element hydrogen. Now, you cannot look up the isotopes in the periodic table since they are naturally occurring. It's not something you memorize. It's not something you can get directly off the periodic table, but you can look it up, okay? And I know that hydrogen has 3 naturally occurring isotopes, and every isotopes or every atoms, of course, has a nucleus. And we're gonna talk about now what is the same and what's different about these patterns of the 3 isotopes of hydrogen. Of course, all atoms have nuclei, right? So hydrogen, if you look on your periodic table, this is element 1. So therefore, that is the atomic number. And that means every atom of hydrogen has 1 proton in its nucleus. So in order to be neutral, it also has to have 1 electron. So every neutral atom of element hydrogen has 1 proton, okay, and 1 neutrons. That's the thing that's the same about all neutral atoms of hydrogen. So what's different? What are the isotopes? Well, as I have said, atoms of the same element with a different number of neutrons are called isotopes. One isotope of hydrogen has no neutron. Okay? Another isotope of hydrogen has 1 neutron. And then the third one has 2 neutrons. So, okay, we're not that done. Okay. So now, so these are the three, okay? So what's the, okay. So one isotope of hydrogen has some neutrons. Okay, so hydrogen has three. Actually, some elements or atoms have 4 or 5 isotopes. Okay, so hydrogen happens to have 3 isotopes. So what is the same are the number of protons, the number of electrons, and what is different is the number of neutrons. Okay. Okay, so these represent the total number of protons and neutrons in the nucleus of the atom. So protium is also hydrogen 1. Deuterium is also known as hydrogen 2. And then tritium is also known as hydrogen 3. All right. Now, the atomic number we talked about earlier is the number of protons in the nucleus of an atom. Now, the mass number is the sum of the number of protons and the number of neutrons. So you just have to add up the number of protons and the number of neutrons, and you get the mass number. Now, please remember, the mass number is not the mass of an atom or the mass of an element. All right? However, mass number is equivalent to the whole number of atomic mass. Okay? And also, the atomic mass, as we discussed earlier, is the weighted average mass of all the isotopes of the element and can be found in the periodic table of elements. Now, I'm going to show you how we designate this by their what we call isotope notation. So the first step is to write down the element symbol. So in this case, our example is magnesium with a symbol of Mg. Okay, and the mass number will be written here. Okay, so this is the mass number at the upper right left-hand corner, which is also equivalent to the sum of the number of protons and the number of electrons. Okay, or it is the sum of the number of protons and the number of neutrons, where the number of neutrons is equal to, okay, the difference between the atomic mass and the atomic number. Okay, and then the next thing we're going to write is the number 12. So what does number 12 stand for? So 12 is the atomic number. Okay, so as we discussed earlier, the atomic number of an element is what distinguishes it from all other elements. So an atom's atomic number is the number of protons there are in the nucleus, which is also equal to the number of electrons. Okay, so hydrogen's atomic number is 1. Helium's atomic number is 2. Okay, you can look at your periodic table. So any atom that has an atomic number of 1 is a hydrogen. Okay, so no matter how many electrons or neutrons the atom has, atomic number of 1 will always be hydrogen atom. Okay? Now, how many protons, neutrons, and electrons are there in the neutral atoms of the naturally occurring isotopes of carbon? Okay, the symbol for carbon is C. So carbon has 3 isotopes. Okay, so we have carbon 13, carbon 12, carbon 13, and then carbon 14. Okay, so what is this number? This number is the mass number. Okay, so the mass number is the number of protons and the number of neutrons. Okay, so now if we look at your periodic table, okay, try to find carbon. All right, so carbon is up in the top right hand side. So it's element number 6. So that number 6 is the atomic number. Okay, and that number, okay, that number 6 is the number of protons in the nucleus of every carbon atom. So every carbon atom has 6 protons in its nucleus, regardless, okay, regardless of which isotope it is. And for a neutral atom, the number of protons is equal to the number of electrons, okay? So the number of electrons is 6. Now, what about the number of neutrons? So this mass number, okay, so this mass number is the number of neutrons plus the number of protons. So that means the mass number 12 minus the number of protons is equal to 6, which is the number of neutrons. Okay, now the next one is carbon 13. Okay, so it has 6 protons. Of course, it is equivalent to atomic number. And then we have 6 electrons, and 13 minus 6 is equal to 7, which is the number of neutrons. All right, and then the last one is carbon 14. All right, so we have 6 protons, of course, and then since it is a neutral atom, we also have 6 electrons, and then 14 minus 6 is 8. So once again, all right, so you just have to take the mass number and then subtract from it the atomic number, and then you will get the number of neutrons. All right. Okay, so as we discussed in our first lesson, molecule is a group of atoms held together. So here are many substances that exist as 2 or more atoms connected together so strongly that they behave as a single particle. So these multi-atom combinations are called molecules. So a molecule is the smallest part of a substance that has the physical and chemical properties of that substance. So in some respects, a molecule is quite similar to an atom. So a molecule, however, it is composed of more than one atom. So you would know more about molecules when we discuss chemical bonding. Okay, so atoms are neutral. They have no charge. Okay, now an ion is a charged particle, either positively charged or negatively charged. So why is it charged? It's charged because the number of electrons is not equal to the number of protons. Now, how do they become charged? That is by gaining or losing electrons. You cannot really gain or lose protons. Remember that. You cannot really gain or lose protons. They are too tightly held in the nucleus. So an atom, or rather an ion, the charged particle where the number of electrons is not equal to the number of protons. So the atoms which are neutral, okay, become charged when they gain or lose electrons. Now, there are 2 kinds of ions. There's the cation and there's the anion. So when an atom loses 1 or more electrons, it becomes what we call a cation. And when an atom gains 1 or more electrons, it becomes what we call an anion. Okay, it's like let's say an analogy. You can think of it like this: cut or cutting off electrons. You become a cation. Gaining electrons is like adding electrons. You become an ion. All right. Now, when you lose electrons, you lose negative things. Okay. When you lose electrons, you lose negative things, you become positively charged. So for example, sodium atom, it has 11 protons and 11 electrons. Now when it loses one electron, it will become sodium ion or Na positive. All right? Positive charge because it has more protons than electrons. All right. So this is sodium atom. But once it lose an electron or gain an electron, and in this case it loses one electron, it will become sodium ion. All right. So this is an atom and it becomes an ion. All right. Now, when you become, for example, let's have another one. Now, when you become an ion, you gain electrons. You gain something negative. So you become negatively charged. So for example, chlorine atom. Okay, so this is a chlorine atom. It has 17 protons and 17 electrons. Now, when it gains one electron, it will become chlorine ion or Cl negative. Okay, negative charge because it has more electrons than protons. All right, understand? Let's move on to the next slide. Now, the types of elements that form cations are the metals on the left side. Okay, so these are the cations, those elements on the left side. So these are all metals. Okay, and the types of elements that form an ions are the non-metals on the right-hand side of the periodic table. So there are only a few non-metals. So these are the non-metals. And hydrogen. All right, hydrogen is also non-metals. So okay, so these are the non-metals, only a few of them, including hydrogen. And then the rest, they are all metals. Now let's look at some specific groups, some specific columns. So this is the first column. This is the first group of all these elements. In this group, it have one electron in their outermost shell. So when they form bonds, they're likely to lose that electron. So when they lose that electron, they form a positive one charge. So group 1 elements form positively charged ions. They have a positive 1 charge. So from lithium, all right, from lithium to francium, they all have positive 1 charge. Now the next group, okay, group 2, so the beryllium group, they have 2 electrons. So all of these elements have 2 electrons in their outermost shell. So when they form chemical bonds, they're likely to lose those electrons. And if you lose 2 electrons, then you become positively charged and you have a positive 2 charge. Okay? Now this whole block here, okay? So this whole block here in the middle, these are transition metals. Okay, so some of them form different charges. Some of them will only form one charge like silvers. Okay, where is silver? So this is silver. It forms positive one charge, but they don't follow any particular pattern. Okay, so generally you have to look those up. Okay, so you should have to take note of that. You have to look it up. Anyway, we're going to skip over here to group 13, and we're going to talk about aluminum down. Okay, so because boron is not a metal, it is actually a metalloid. So from aluminum down, they have 3 electrons in their outermost shell. So when they form chemical bonds, ionic bonds, they likely to lose electrons. Okay, they likely to lose 3 electrons, and therefore they become positively charged and has positive 3 charge. Now this group right here, okay, so the group 17 or fluorine group, they want to gain 1 electron. When they gain 1 electron, that gained one negative charge thing. Okay, they have a -1 charge. So yes, this group has -1 charge. And then oxygen. All right, the oxygen group, and they want to gain 2 electrons to fill their outermost shell in an ionic bond. And therefore, they're going to have a -2 charge. Okay, so you gain negatives, it become 2 negatives, so you have a -2 charge. And then the nitrogen group, okay, so they tend to want to gain 3 electrons. So if you gain 3 electrons, then you have a -3 charge. All right, so this in the middle here, they kind of can go both ways. Now let's answer this. How many protons and electrons in aluminum ion? Okay, so it has +3 charge. Okay, the mass number is 27 and atomic number is 13. So the number of protons is equal to the atomic number. All right, so therefore the number of protons is equal to the atomic number. So the answer is 13 protons. And then aluminum ion has +3 charge, which means aluminum contains more 3 protons than electrons. So 13 minus 3, so therefore you have, all right, you have 10 electrons. Okay, now, okay, so therefore, so remember, it's only electrons that be transferred, okay? It's only electrons that can be transferred from one atom to another. Now, let's try this one. So how many protons and electrons are in selenium ion? Okay, so it has -2 charge and the mass number is 78. Okay, and the atomic number is 34. All right, so what would be the answer? Okay, so you have 37 protons since it is equivalent to the atomic number. And okay, so the number of electrons you have, okay, so you have 36 electrons. So you have protons, which is 34, and then it is -2 charge. So it would be 34 plus 2. So therefore you have 36 electrons. Okay. Okay, so this time, the first two students who can give me the correct answer will be exempted on the first quiz. And the succeeding three students will get plus 10 on the first quiz, or rather on the next quiz. So you just have to send me a message. So we have PB and we have